Hello friends, welcome to another tutorial in network analysis and synthesis. Today we'll discuss incidence matrix, which is a pretty basic theory of graph theory. In this we have a graph and we find out which branch is connected to which node in which manner. So in other words, this matrix shows which branch is incident to which node. Now, what do you mean by a branch and a node in a graph? This has already been discussed, but still I'll reiterate that the nodes are represented by these small circles or dots, and branches are these lines connecting these nodes in a network. And of course, when you name the nodes, you encircle the numbers. For branches, you do not do that. Now, once we have this graph ready with us, which has n nodes, for example, this graph has 4 nodes and b branches, this graph has 5 branches, and we've also shown the direction of the current flow in the branches. So the incidence matrix will become an n by b rectangular matrix. So this is the first key point. You could put a star next to it. And of course, we'll name that incidence matrix as AI, where each element of this matrix is going to be a small ij. Now please understand, I will be for the node and j will be for the branch. Right, so this is going to be point number 2. And the third point is, if the branch is oriented away from the node, for example, branch 1 is oriented away from the node 1, will assign a 1. If the branch is oriented towards a node, and that could be illustrated by this case, that a branch 1 is oriented towards node 2, will put a -1. Another example could be the branch 3 is oriented towards node 4, so we'll put a -1. And of course, branch 1 is not incident to node 3, so we'll put a 0. So if a branch is not connected at all with a node, that would mean that it is not incident to that node. A branch would only be incident to a particular node if it is connected to it. So there are only two possibilities. If a branch is incident or connected to a node, it will either be oriented away from the node or it will be oriented towards the node. So depending upon whether it is running away from the node, we'll put a 1, and if it is running towards the node, we'll put a -1, and if it has got no relationship whatsoever with the node, we'll put a 0. So if you were to make the matrix AI, so you can say that it is going to be a rectangular matrix of n into b. So number of nodes in this case are 4, number of branches are 5, and each element is going to be a and then node and branch. For example, this element will be 1 1, node 1 branch 1. So this is going to be A1 2, A1 3, A1 4, A1 5, and so on. This is going to be 2 1, 2 2, 2 3, 2 4, 2 5. I'll fill this up quickly. Now once the elements are written in the matrix, we'll start inspecting them. For example, A1 1. Let's talk about node 1 and branch 1. The first thing is branch 1 incident to node 1? Yes, it is. So branch 1 is connected to node 1, but it is moving away or going towards, so it is moving away, so we'll put a 1 here. So this will become a 1. Now let's talk about 1 2. Is the branch 2 connected to node 1? So 1 represents the node, 2 represents the branch. Is the branch 2 connected to node 1? No. So we'll put a 0 here. 1 3. The branch 3 is also not connected to node 1, so we'll put a 0 here. Branch 4 is also not connected to node 1, so we'll put a 0 here. And branch 5 of course is connected to node 1 and it is moving away, so we'll put a 1 here. Now let's talk about node 2. Is the branch 1 connected to node 2? Yes, and it is moving towards it, so we'll put a -1. 2 2. Yes, branch 2 is connected to node 2 and it is moving away, so we'll put a 1 here. And similarly 3 is not connected to node 2, so we'll put a 0 here. 4 is moving away from 2, surely it is connected, so we put a 1 here. 5 has gotten no relation whatsoever to the node 2, so we put a 0 here. And similarly you can fill the entire table. -1 because 2 sure is connected to 3 and it is oriented towards it. And a 1 and a 0 and a 0. You should see it for yourself. I'm going to quickly complete this table for your reference, and then you can pause the video and do the calculations. So this will be your incidence matrix, and this complete incidence matrix is also known as augmented incidence matrix. And we'll talk about the usage of this matrix in solving a number of questions, and we'll also do the reduced incidence matrix in the coming videos. And I hope this video was of help, and this elementary theory about graphs of a network will help you. If you liked the video, give it a thumbs up. Consider subscribing to the channel also. That will be a great help. I'll see you in the next one. Take care and have a good life. Bye.